Hello. Here we discuss what is called level sets and their relationship to isoquants and indifference curves. The definition of a level set is right here. We take a function of two arguments, f, x, y, and we fix its value at some constant. So then we obtain some relationship between x and y, and this relationship is called a level set. Okay? So I'm going to do it in a minute. I'm going to show you the plot, but this is what you have to imagine. We can consider a function in the three-dimensional space like z equal to this fxy. And then it will be, that function will have a surface in the three-dimensional space. We cut that surface at a height equal to this constant. And in the intersection of the surface and the plane, drawn at this constant, horizontal plane drawn at this constant, at this height, we obtain some curve. So this will be that level set. Okay? So let's look at a couple of examples. Here is the first example. This is the production function, Cobb-Douglas production function. Don't look at the rest of this command. It may be confusing. So we cut the surface of this production function with horizontal planes, okay? And this is what we get. Here's the result. I can turn it a little bit, okay? So we can see that uh, one horizontal plane is drawn at this level, the other at this level, the third one, and so on. And by looking from above, we can see shapes of those curves. These are the shapes, okay? And when we project those curves on the KL plane, in general xy in my original notation, on KL plane, when we project those curves, we obtain those level sets. Level sets are formulated in terms of the independent arguments xy in general case or KL in my case that I consider here. Okay. Now those level sets that you can see here from above, this may be too dark for you to see, but I hope you can see it. Okay, those level sets, they should be familiar to you, and this is what people draw in economics all the time. Okay, in case of a production function, we draw isocosts. Okay, here are isocosts. It's along those curves the production is constant, and this is exactly what we get from here. So this is the picture that I'm showing here is three-dimensional. Once again, we cut this surface with horizontal planes, and then what we obtain in the intersection is projected onto xy plane, and what you see in economics courses, those isoquants, they are actually, using that general terminology from mathematics, they are actually level sets. Okay. Now I want to discuss the same thing in a different context. Instead of talking about a production function like this, we can talk about a utility function. So a utility function with two arguments. Instead of k, we can think about good 1, and instead of L, we can think about good 2. So the level sets in this case would be called indifference curves, okay? And again, they are obtained in exactly the same way. We cut the surface of the function in the three-dimensional space with horizontal planes, and the curves that are obtained in the intersection are projected onto the plane. And again, we get something familiar. This would be indifference curves in case when the original function of two arguments is a utility function. And I think it is important to understand this three-dimensional interpretation, because absolutely all economics textbooks that I have seen, they show only what happens on the plane, okay? But in fact, there is this three-dimensional picture behind those plane pictures. And this is also important to understand in the context of optimization. Okay, so making one more step towards optimization, I want to show you the picture for budget constraints. Okay, now let's look at this expression, 0.5k plus 0.5L. This is a linear function, and it could be interpreted like this, that 1 unit of k costs $0.5 and 1 unit of L costs $0.5. Okay, so what is written here for the given levels of K and L, this will be the total cost of hiring that much K and L. Okay, and you can see here the resulting surface. Since this is linear in K and L, here we get a plane. Okay, and the isocosts would be those lines that we obtain when we draw horizontal planes and we look at the intersection of horizontal planes with this plane that we have here. Okay, so when we project those isocosts on the xy plane, then we get the usual budget lines. Okay, budget lines are constant along such let me say it from above. Okay, so this would be in the projection, this is what you get. This would be one budget line, this would be another budget line, and so on. So looks like this is all about the definition of level sets and the geometrical interpretation. Thank you. Bye.